And welcome back. As we go ahead and take a look at how to build our own recursive methods, let's go ahead and take a look at this with a very simple example here to kind of work through some of the steps of how to do this. So here I have created a kind of structure for us to use, and we have what these methods are supposed to do. It's supposed to display all integers from 1 up until that number. And you can see I have a iterative and a recursive method kind of started here. You'll notice with our recursive method we have gone ahead and set up an if else, so we're looking at 2 cases here. Now of course we could have multiple other cases, but again, because we're using something simple here, I think 2 cases is a good point to start. And if we think about this, we want to run from 1 to a number. So let's go ahead and approach this with the recursive method definition first to go ahead and take a look at that. So if I want to go up to a certain number, the way we're going to kind of work this recursively, because remember, we're not going to work up to a number, we're actually going to work backwards because of how the last in, first out stack works. We have to kind of think backwards about this. So since our parameter is num, let's just say we want it to, and it says it's going to 1, we have to say something like less than or equal to 1. Because what that's going to do is say, hey, as long as this is less than or equal to 1, this is going to be our stopping point. Because where do we want this to stop? We want to stop at 1 because that is a number we know for certain is going to happen. Now we could restructure this if we wanted to go to num, but that would be something maybe more like a count up. But we're, again, counting down is a way to think about this. Because again, remember, it's going to work in that last in, first out structure. And all we want to do here is simply just return whatever num is. And so I can say, okay, if it is less than 1, go ahead and print it. Now, what about the recursive side? Well, remember with the recursive side, it's always going to be the name of your method. So we have a recursive method, and we are going to pass in some type of number. Now, a good way to think about starting this is we're probably going to do something with our variable. And so I'm just going to start with that. And if I think about this, I say, okay, recursive method num. If I leave this as is, what do you think is going to happen here? If you said it might be an infinite recursion, you're correct. Because guess what? It's just going to keep calling that same number over and over again. And it's never going to change. So what we need to do is actually add something in here to change that. All right. Like we looked at, for example, our right vertical method, we had things like division and modulus and stuff going on. So here, though, because we're simply just going 1, 2, 3, 4, 5, what are we doing? Well, we're counting up. But remember, because we're working backward, we won't be adding 1. We're going to be subtracting 1. So again, that's the big thing to remember with recursion when you're trying to build your algorithms is that you have to think about it backwards. It's not how do I work through this, 1, 2, 3. It's more like how do we work 3, 2, 1 to get to that starting point. Now, if I leave this as is and I just go ahead and run it, I have, of course, 5 here just as a tester, and I just run it, you notice I just get 1 printed out. And that's good because that means I don't have any infinite recursion or anything like that, but it says it's supposed to display all integers from 1 to that number, which means what am I missing? I'm missing probably a print line statement. So I'm just going to go ahead and add out in here a system.out.println, and I'm just going to output num again. And now if I go ahead and run that, oh, we got 1, 2. So did I forget something? Yep, I put a print here instead of a print line. There we go. That's fixed. Now we have 1, 2, 3, 4, 5. Awesome. Now, I want to, of course, walk us through the iterative approach just so you can see how this is different. Now, with the iterative approach, we're probably going to need a loop. So let's just go ahead. I'm going to create another int here. Let's just call this start. And I'm going to set that equal to, let's say, 1 to start. We can, of course, change that if we need to. We make it like 0 or anything like that. And again, we need a loop. So let's use a while loop. And we'll just say while start is less than num. That's a good way to kind of get a start here. We can, of course, adjust this if our algorithm development is wrong. And all we want to do is pretty much have it display out each of these numbers. All right. Since we're, of course, thinking about 1, 2, 3, 4, 5, well, we know we want it to display that out. So let's just go ahead and do a system.out.println, and let's just print out start. However, because I have just a plain less than, that means it's never going to perform exactly what we want. Don't forget your increment here. So there we go. Almost forgot that. We have to make sure this is like a less than or equal to, because otherwise, based on how this increments, it's not going to work. Now, if we had started at 0, we could do the increment first. But again, we want to make sure we hit those numbers. Let's give a quick run here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Boom. Looks good. Now, this again is a very simple example at how to build out a recursive method versus an iterative method. So in this example, you can see it's pretty simple, but I did have to think about this a little differently. So for example, here I need another variable to kind of keep track of things. I couldn't just say, start at 1. Now I could, of course, maybe rearrange this Boolean expression a little bit and does some work with num to try and do this. But this was a quick and easy way for me to handle this, but just using a temporary local variable and comparing it to the parameterized one. In my recursive method, though, remember, all I had was these two cases here, and I didn't have to worry about keeping track of another variable. So ultimately, though, it becomes kind of a little bit of programmer preference as to which one that you use. Remember, the iterative methods do have an advantage of technically being faster because they're not handling stacks, and the iterative ones are going to be a little bit more complex as we get into more complex versions of recursion. Whereas the recursive methods, there's going to be certain tasks that lend themselves very, very well to recursion versus some of the things you might have to do with iteration. Again, this is a very simple example to kind of show how those two versions are different, and hopefully that gives you a little bit of clue as how to start approaching this to write your own recursive methods.